Hello, welcome to the module C data types. In this module, we'll discuss how the data types from a Yang data model translate to the C programming language and the common structures you'll use when working with the ConfD APIs when programming. The key part of this is in the documentation in the ConfD types man page in section 3 of the manual pages. This is a manual page you will certainly want to read through after watching this module to become more familiar with the C data structures you'll use while writing C code and working with ConfD. Here we see the ConfD types man page. One of the first things you'll see is an enumeration declaration of various data types. These map to the Yang data model types, and one of the first things you need to know is which of these types correspond to a Yang data model type. There are a couple of ways of doing it through this manual page. The easiest is to go down to the section called Data Model Types in this man page, and here you will see a list of the various Yang data types, such as here we see int8 from Yang, and we see that its type corresponds to C_int8 along with some other information. The key part here is the CInt8, which that indicator we'll need to know a little bit later. Now, the fundamental data type when working with the C APIs with ConfD is what's called a ConfD value T. That's the most fundamental type that you'll first start working with. There are also two other types and structures that you will work with. One is called a value array, and the other is the tagged value array. Let's first talk about the ConfD value T. In the header files, which you'll include in your C programming, is a structure that you see here called ConfD value, which at the end of the structure definition you'll see it's ConfD value T. This structure provides a tagged union. There is a type tag, which is this first field of ConfD v type. This is where the C underscore definition from the enum that we were just looking at will be placed. The rest of the structure is simply a union that you can see here has various different data types in it. This is the ConfD value T. Now, the good news is you do not have to manipulate this structure and the unions directly. We provide an extensive set of convenience macros with ConfD, which you'll use in your code when accessing this data structure. So, we had just, for example, looked at the int8, and we saw that it uses C_int8. Below the definition of the ConfD value T in the documentation, there are sections with all of the various different C underscore definitions. Let me go down to CInt8, since we were using that as purposes of example. So here I found CInt8. Also here, there's a note that it does represent the Yang type of int8, and then a small C sample showing use of the macros for accessing the ConfD value T. For all data types, in general, there is one set macro and one get macro. So there's ConfD set int8 and ConfD get int8. So you'll have your set and your get macros corresponding directly to the names of the C underscore name. So you simply, to use the set macro, have declared a ConfD value T, and in the set macro provide a pointer to that ConfD value T and the value that you wish to place into that ConfD value T. Similarly, for reading the value, you'll use the ConfD get int8 macro, provide a pointer to an int8, and you call the macro, and that's the returned value. There are a couple of data types for ConfD value T which have two macros involved in setting and getting. This is when you are working with the CBuff type and CString and a few others. In the case of a CBuff, which represents a Yang string type, you have actually a run length encoded string structure that is worked with. In that case, your setBuff macro for setting a CBuff has the pointer to the ConfD value t, your string, and a length of that string. So there are 3 parameters on the set call instead of 2. And then for reading, you have 2 different get macros provided. One gets you a pointer to the buffer, the other provides the size of what's in that buffer. Similarly, you can read through this section of the documentation and learn how to work with other Yang data types in your C structures. There is also then the value array data type that is used in some of the API calls, and when you're reading the detailed API documentation, if it says it uses a value array is simply an array of ConfD value t's. You'll simply declare the array in your code, and as necessary, use the set and get macros on individual elements of that array, and then provide a pointer to the first element of that array in the API call. The value array is documented in the XML structures section of the ConfD types man page. The third data structure you will work a lot with is the tagged value array. A tagged value array manages to not only convey data values and types, it also conveys structural information about your Yang data model. Sometimes you need to provide something that is a set of different values. For example, in the various set or get values API calls, those values may be scattered around your data model in different locations, and we need to understand where they are. In other calls, there may be structural information from the data model that needs to be conveyed. In those cases, the tagged value array structure is used. Here, we see the definition of a tagged value array as a ConfD tag value t, which provides 2 elements in the structure. One is called an XML tag. The other is simply the ConfD value t. The XML tag provides information regarding the element from the Yang data model. Remember, a Yang data model is really an XML schema definition. So that structure of the XML schema from the Yang data model is what the XML tag is conveying. When you build your programs, you'll compile the data model into a binary form known as an FXS file. The ConfD tool is used to take that compiled data model and will generate a header file of various hash codes and symbols corresponding to symbols from a Yang data model. Let's take a look at a brief example of that. In the 2 terminal screens that you're seeing, on the left is a basic small Yang data model. We can see the structure, the ARP entries container, the list called ARPy, and various leafs that are contained in that list entry. On the right, we see the header file that's been generated as a result of this data model. If you look at this generated header file, you'll first see some defines related to the namespace which has been declared in the Yang data model, and then as well as a set of symbols and hash codes that have been generated from symbols that have been found in the data model. So for example, we see this first pound define ARPy permanent and a number. And you see in the Yang data model, one of the entries in the ARPy list is called permanent. In general, these pound define symbols are a combination of the prefix which you defined for the module along with the symbol that has been found. So when we are working with the XML tags in the tagged value array, if we need to refer to the leaf called permanent in our data model, we'll use this RP permanent as the XML tag that is used in the tagged value array structure. Now, let me go back to the documentation here. So, in the documentation of the tagged value array, similarly to value array, you will find information about when and how this is used, and then a sample that shows how these are used. Similarly to how we had the ConfD set and ConfD get macros for the various data types such as int8, uint32, string, etc., there are similar set and get macros for tags. So if we're going to set up a tagged value array for a data model that had 3 elements that we need to include in this tagged value array, we would use the ConfD set tag macro followed by the type. In this case, the first element that we're setting was generated from a data model who had a prefix of servers and a leaf named name. Name had type string in that model, so we use ConfD set tag string. We point to the first element of our tagged value array. We provide the XML tag or hash code that was generated along with the value we wish to set in there. Similarly, for other elements, and when we're done running the various set tag macros, we've built our tagged value array. If you've made an API call, which has returned a tagged value array, you'll want to get the values out of it. In that case, you'll use the various get macros. So if we want to, from a tagged value that has been returned to us, in this case it isn't an array, it's simply an array of length 1. Here, to get the tag, we call ConfD get tag tag on that tag value t, and that tag value will be returned. In this case, we're comparing it against the XML tag or hash code that has been generated for the leaf named port in the server's namespace. Then, if we wish to extract the value, we simply call ConfD get tag value. This will return the ConfD value t that is within that tagged value, and then we'll use the standard get simple type macro. So in other words, if the port is declared as a uint16 in the Yang data model, here we call ConfD get uint16 against that get tag value, and we'll have the value. So with that, we've taken a look at the fundamental data structures you'll work with in your C code when working with the ConfD APIs. Again, those structures were the ConfD value t, the value array, and the tagged value array. Full details of those data structures and working with them are found in the ConfD types man page in section 5 of the man page documentation. Thank you for watching this module.